this lesson, we're going to look at piecewise functions, and we're going to try to do some more complex examples. So let's start with graphing each of these individually. So if you look at x squared minus 4, remember this number, since it's outside of the square part, it means you move it up or down, and we're going to move it down 4 units. So as we look at this one, we're going to go ahead and graph this one with -4 to start with. And then it will go up from there. For instance, if I put in a 2, 2 squared is 4, 4 minus 4 is equal to 0. And same with -2. -2 squared is 4, and if you subtract that, you get 0. So this is what my graph looks like. If I were to graph the entire x squared minus 4. Now what this says is only use a domain of less than or equal to 0. So what we're going to do is we're going to erase all of the domain that's the positive value. It's going to stop here at 0. So we only get half of the parabola. We get the half that goes to the left side of the axis. We're going to do the same sort of thing here. Graph the whole thing and then erase part of the domain because of the restriction. So 6 minus x, another way to think of this is y equals -x plus 6. You can commute the two of those. This has a y-intercept of 6 and a slope of -1. So we'll start at positive 6 up here. A slope of -1 means we're going to go down 1 over 1. I'm going to think of slope here as -1 over positive 1. So down 1 over 1, down 1 over 1, down 1 over 1. You draw that line. Now this is going to be a domain of greater than 0, meaning it's going to be the positive numbers. So I'm going to erase this part of the domain. And then at 0 itself, I'm going to put an open dot because it does not include that. It's not or equal to with that domain. This one was closed because it was or equal to at 0. But here we don't want the number 0, but we do want all the decimals and fractions between 0 and 1. So don't start at 1. Go ahead and just put an open dot there to represent it doesn't include that. So now that's the restricted domain on each of those. Let's go ahead and put those together, combining these two. So we're going to take these two and combine them. I'm going to take this graph here. I'm going to write it on this my graph here. So -4. I'm going to draw this graph. And then I'm going to do this part, what I did up there. I'm going to put that on the graph. So you'll see it start at 6 here. And I'll go down like that. So notice this piece gets put on it, this piece gets put on it. So it's like I treat each of these two as separate problems. I do this problem, I do this problem, and then have them on the same graph. That's why it's called a piecewise graph. All right, so one extra thing I want to add to this is, what if I ask you for values of this function given these x values? What are the y values? Well, when I ask you for these values, for instance, -3, -3 would be, where does this graph hit over here? If I have an x value of -3. Well, if I put in -3 here and square it, I get 9. 9 minus 4 would be a 5. So it would be this point right there. So this graph would have gone through that point. So f of -3 is equal to 5 because we use this rule, x squared minus 5, x squared minus 4. You put in -3, -3 squared minus 4, and you get out a 5 as a result. So for these values, I'm going to put 4 in. Which of these categories does 4 for an x value fit in? Well, 4 is greater than 0, so I'm going to use this rule. I'm going to take and make it 6 minus the 4, which will equal 2. And notice at 4, I'm over here at 4, It's that point right there. 4 goes with 2, goes right through that. Now what about 100? It doesn't even show up on my graph. So an x value of 100, which of these two restrictions does it fall into? It falls into this one. 100 is greater than 0. So I'm going to use this rule. 6 minus 100. That's going to give me a negative 94. So those are when you're trying to find values for function values, you see which of the domain restrictions it falls in, put the value, the x value, and define the y. All right, let's do some more examples. Let's try these. All right, so these are a little more complex, notice, so we'll do a couple examples that are pretty complex. So remember these values here. I'm going to go with x is less than negative 4. When it doesn't have an x with it, that just means it's a constant. So my x equals to 2. I'm going to do these in different colors just to kind of show you. But x is equal to 2, or excuse me, y is equal to 2. Remember the graph of it looks like this. It's a horizontal line at 2. But what this restriction says is, let's just go less than negative 4. So I'm going to erase all of this out to negative 4. And which kind of dot am I going to put on it? Because it's just a less than, you're going to put an open dot on it. So now let's go ahead and go to, let's see, I'll do red next. And on this one, negative 5, a graph of y equals negative 5 would look like this, straight across at negative 5. Now this is saying, let's stop it at 0, not including the 0. So let's stop here at 0. This is x equals 0. Notice x equals 0 right there. Let's go to negative 4 on the other side. So it's going to erase on this side and stop at negative 4. And this one, it includes that point at negative 4 because of the or equal to. Notice that idea of taking the graph and restricting it according to this domain. So I'm going to graph this one here. This is a parabola because of the square. This is saying move it over 2 units. I'll do this one in, let's do this one in black here. So it says move it over 2 units. So you move it over 2 units to the right, and then I move it down 1 unit. So the graph would start here. And then I'm going to go ahead and put in different values. Now here's an advantage. I'm actually going to put these values in to see what happens to those points. Put in the endpoints into the rule. That will help you figure it out. So put in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 1 is 3. So I'm going to put in 0 and get out 3. So the graph looks like this over here. Okay. And then I'm going to put in the other endpoint, put in a 4. 4 minus 2 is equal to 2. 2 squared is 4. 4 minus 1 is equal to 3. So I'm going to go ahead and put in 4 here, go up to 4. Now it's including it, so it's going to be a solid dot. And so I'm going to draw the graph like this. So I've got this part of the parabola restricted to stop there. The big hint there for doing these is do the endpoints to see where the graph goes. Lastly, this is a line. If I want to do this line, what I want to do is I could start at my y-intercept of negative 4 down here, and I could go up 2 over 1, up 2 over 1, etc. Well, why not start at that endpoint right there? Put in the 4. 4 times 2 is 8. 8 minus 4 is equal to 4. So I'm going to go to the point 4, comma 4, and I'm going to draw an open dot here because it doesn't include it. And from that point, I'm going to use my slope of 2, up 2 over 1, and draw the graph. Notice if I had started down here, if I had started down here at negative 4, and I started here and gone up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, it would have had me end in that exact same place. All right, so there's my piecewise graph. This first part is this piece. This part here is the second piece. This parabola is the third piece. And that last piece is that line. All right, let's go ahead now and look at the next example. let's try this. Let's go ahead and we'll do this one in green. All right, so for this one, again, I'm going to do a constant of 5, and I'm going to go all the way to -3. So I'm not going to do the whole thing this time. Instead, I'm going to do here's 5, and I'm going to get to -3 here, and I'm going to put an open dot on it, and just have this piece of the domain. Let's do this other one. I'm going to do x plus 1, but I'm going to use these endpoints to graph it. I'll do this one in red. Okay, so let's do -3 plus 1 so I'm going to start at x equals -3, add 1 to it, and you're going to get a -2, so it'll be down here at -2. It's included because we have the or equal to on it. Let's put in the 2. 2 plus 1 is 3, so at 2 I'm going to end up at 3 here, and it also is included because it's got that the or equal to on it. And now I'm going to just connect those two and make it into a line like this. So it's from that endpoint to the other endpoint, okay? All right, now let's go ahead and do the last one. That's a constant, -6. I want to do it from 2 and above. Let's go ahead and do this one. I'll do this one in blue. Now, if I go -6 here, I'm going to go down here to -6 and come out to x equals 2, do an open dot right there, and then it's a constant, so it's a horizontal line going to the right. So piecewise graphs are looking at each of the functions, take the restricted domain, and graph them all on the same graph. Let's go ahead now and do a couple values, okay, or a value at least. So after we've done the graph, we can look at the value itself. This is saying what happens at x equals 0. So this is an x value equal to 0. So when you look here, where does 0 fall on these different restrictions? Well, 0 falls here, so I'm going to use this rule. So if I put 0 plus 1, okay, 0 plus 1 is equal to 1. Notice that's exactly right here. That's that point right there that shows up on my graph. So these are more extensive piecewise graphs. Sometimes you'll have several rules to deal with. Just focus on the restricted domain, use that rule with those x values, and you'll get your entire graph.